So welcome everyone in the 2D coordinate geometry class. Relatively easy compared to algebra and other different things for IIT JEE or class 11th and 12th. So algebra looks easy, but they create difficult problem. There is many other way the problem could be created, and it could be difficult to solve if you have not already done so. But in coordinate geometry, if you really know the concepts well and if you try to do it, you should be able to do these problems even in IIT mains or advanced. So to do the questions in 2D geometry, see all the videos that I started, and I will create more videos. And in terms of the books, you can follow any books, but I will list out the books, but the books are not important, but the questions behind each chapter is important. So you can look at the NCERT book, SL Loney, very classical book, but they deal with some of the substances that are not part of the course. For example, they deal with the axis inclined to some x-axis, things like that, but it's still a very good book. You can look at ML Khanna guide for all the problems if you are especially preparing for IIT JEE. Once you do the chapter, you do all the chapters, and then you can refer to this ML Khanna book, and then you can look at the chapter wise previous year question. So once you have done all the problems, for example, and if you are feeling confident, take all the problems of one chapter from IIT mains and then IIT advanced and do all the previous year questions from that particular chapter. NCERT is very good for concept, they take time to explain, but if you look at this video and go directly to start doing the problem, that will save you a lot of time. So if you look at the number of chapters are few in 2D geometry. They are only the first chapter, maybe 2D coordinates. We'll talk about the coordinate. We'll deal only with the points. We'll deal with the triangle area, section of point, midpoint, and things like that. Anything that has to do with the coordinates of the point. And then we have straight line, in which we'll talk about there is a straight line and we have its equation. And there are a lot of different ways the problem, it looks very simple, but there are many different ways problem could be formulated. Perpendicular lines, angle between the lines, lines intersections, so on and so forth. There is a chapter on pair of straight lines, which is not part of the IIT, but it's part of many board exams, and it helps if you understand pair of straight lines in other later chapters. My suggestion will be to go through this as well, even if it's briefly, even if you are preparing for IIT. Then we have circle. This chapter will be a little long, it will take a long time, maybe 3-4 lectures on just the circle itself. Because if you understand circle very well, then the next chapters will be easy to follow. Make sure you spend quite a lot of time in circle. And then we have conic section that has divided into parabola, ellipse, and hyperbola. Once you do circle really very well, then you can do parabola and ellipse quite easily. Hyperbola is a smaller section, but that is also a part. A lot of questions will come from parabola or ellipse, and then some from circle, straight line, so on and so forth. In the last, I'm not sure, there is 3D geometry. So if it's in the course, we will touch briefly about the 3D geometry. But this should cover the, if you look at this, the number of the chapters are very few. All you have to do is, sometimes 2D and straight lines are considered to be just one chapter. because 2D coordinates are actually class 9th and 10th course, not really, but because we will deal with some advanced type of problem, that's why we are using 2D as a separate chapter. But these two are basically essentially one big chapter, and then circle 1, 2, 3, 4, 5, just five or maybe at the most 7 chapters, and that's all you need to do. But if one good thing about 2D geometry is you don't forget there are not a lot of formulas into it. You need to memorize very little as compared to the trigonometry, where you have a lot of formula to memorize. One more book I wanted to add here is Gorakh Prasad. It's very concise book, and it's not as elaborate as Saloni. It's concise and but to the point. So it's like written in a very mathematical way. All these are very classical old books, but still very relevant. You don't need to go to any modern books, something like that. Most of the math concepts are very old. So we will start with a review of class 10th coordinates in 2D geometry, where we put a two axis. We call this one as x-axis, and this one is y-axis. And a point on this coordinate axis is represented as a distance measured on the x-axis. X-axis, we count the numbers. This is called the origin. The intersection of these lines is called the origin. And from the origin, if we go in this direction, we measure the distance in plus. And if you go into this direction, opposite direction, we measure the distance in minus. And the y-axis, if we go into the up direction, we count as plus. And if we go into the negative direction, we count it as negative. So a coordinate in this whole plane is represented by something like a number 2, 3. And 2, 3 means we need to go 2 in the x-axis direction. This is 1, 2. So if I go 2 distance here, I reach here. And then I go 3 in the up direction. So I reach here 1, 2, 3 here. So this point P will have a coordinate 2 and 3. In the same way, if I am asked like 5 and 7, then I can go 5 in the x-axis direction, 1, 2, 3, 4, 5, and 7 in the y direction. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 6, 7. So this point will be 5 and 7. So that way, any type of coordinate geometry problem, you should be able to visualize where these points are, because joining these points will create a straight line. There may be circles that will have some point. We should be able to visualize the things where the points are. And then the same way, we can also have negative numbers. For example, if I am asked what is minus 2, 3, then in the x-axis direction, I go in the negative direction. That will be called 1, 2, minus 2 is here. And in the y direction, positive is upside, so I go 3 up. So 1, 2, 3. So this point P will be minus 2, 3. If I am asked where is minus 2, minus 3, then again the same thing. Let's catch the x thing. It is minus 2 here. For positive, we have to go here, and for negative, we have to move in this direction. So minus 2 is 1, 2, minus 2 is here. And then minus 3, for positive y we go here, for negative y we go down. The second number indicates the direction in the y. So minus 3 will be 1, 2, 3. This point will be minus 2, minus 3. 1, 2, 3. And finally, we can ask like 2 and minus 3. Try to figure out where this point will lie. So 2 means I need to go in the positive x-axis direction. So this will be 2 here and 1, 2, 3. Minus 3 here. So 2 and minus 3. We can be given any point. For example, let's say I ask you again, where is my point minus 3 and minus 4? Then minus 3 means you go negative direction in the x-axis. So 1, 2, 3, 4, and 1, 2, 3 here in the x-axis direction, and 4 in the negative y direction. 1, 2, 3, and 4. So this point will be minus 3 and minus 4. So you notice that in this first coordinate, both of these numbers are positive and positive. Very similar to what we probably have learned in the trigonometry. In this one, the x is negative, so the first one is negative, and the second one in the y direction is positive, so it's negative and positive. In this coordinate, in this section, third quadrant, we go negative and also y is negative, so both of them are negative. And finally, this one, x is positive and y is negative. It's positive and negative. So this is the coordinate we have already learned about class 9th and 10th. We will move on to some of the things and the questions, distance between 2 points, and learn about these things. So let's say I ask you a question, find the distance between points 1, 1 and 4, 5. How do we do that? Simple problem. First we locate where this point 1, 1 stays. So this is 1 here, 1 here. So let us call it a point P, and I am calling it 1, 1. Let's call it point P, 1, 1. The second point is 4, 5. So 1, 2, 3, 4 here and 5 here. 1, 2, 3, 4, 5. This is called Q, is 4 and 5. If I join this line, I'm asked to find out what is going to be its length. So how we do that? The trick is, we try to make a right angle triangle. Let's say I make a right angle triangle, and let's call this point R. If I know this side PR and if I know this side QR, I can find PQ. So in this one, what does this number 1 indicate? 1 is this distance 1 here. And this 4, 5, this number 4 is nothing but this side. This is how we got 4 here. That means I can find this PR as 4 minus 1, which will be 3. So PR is equal to 3. And next we are going to turn our focus to RQ. What is this number 1 in this coordinate indicate? It is its distance like this one. This distance is 1. And this coordinate of Q, this number 5, indicates its distance from this axis. This distance is 5. It means I can find out QR from 5 minus 1, which will be 4. So this distance is 3, this distance is 4. I can find out PQ using the Pythagoras Theorem, 3 square plus 5 square. That will give us, 4 square. 3 square plus 4 square, golden triangle. This is square root of 25 or 5. The length of these 2 points joining P and Q will be 5. We are going now to derive a general equation for the distance between 2 points. What we are given is, find the distance between 2 points, and its coordinates are given by as x1, y1 and Q is x2, y2. We are given any two general points. P is as x1, y1 and Q as x2 and y2. And we need to find out the distance between these 2 points. We join these 2 lines and the coordinate of P x1, y1. x1 means this distance, just from the definition of the coordinates of x1. Measurement along the x-axis. In the same way, for Q, x2 means the measurement along the x-axis, this distance x2. This is what is given. We create this triangle, call it PQR, and in this triangle, this distance is going to be x2 minus x1. In the same way, from P x1 y1, the second number y1 indicates the measurement along the y-axis, so this distance is y1, and in the same way this distance is y2, which means that we can find out QR from subtracting y2 minus y1, so this distance needs to be y2 minus y1. And now in this right angle triangle PQR, we can apply the Pythagoras theorem. PQ square is equal to PR square plus RQ square. PR is x2 minus x1 and QR is y2 minus y1. We can write it x2 minus x1 whole square plus y2 minus y1 whole square. From here we get PQ square is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, and this is supposed to be a standard formula. If you are given the coordinates of 2 points, you can directly write the distance between them using this formula. In this formula, there is a special category. If, let's say, one of the point, let us say Q is origin, and this origin has a special coordinate, it is 0, 0. So if I ask you what is the distance of this point P from this origin, and that distance will be distance from origin will be equal to square root of x2 and y2 becomes 0. We can write it as x1 square plus y1 square. The distance of any given point from the origin will be square root of x1 square plus y1 square. So this is about the distance of between 2 points. There will be some few questions we will do, but before we do those questions, let us learn a little bit more, try to get a feel of this point. So we are given 2 points, and what else can we know about this line? One thing we want to know or learn about this point is we may be interested into finding out what is the angle this line makes with the x-axis. Let us call this a tan theta, and we are interested in finding out what is the value of this tan theta. And we already have seen earlier that this distance is x2 minus x1 and this distance is y2 minus y1. And from here we can find out the value of tan theta, and that will be equal to y2 minus y1 divided by x2 minus x1. And this particular tangent of this angle is given a special name, and this sometimes called gradient, or it's written as m. M is equal to y2 minus y1 divided by x2 minus x1. There are some special cases. If a line is parallel to the x-axis, you are given a Cartesian coordinate. If the line is parallel to the x-axis, then tan theta will be equal to 0. If a line is perpendicular to the y-axis, then tan theta will be equal to 90 degree or infinity. Line parallel to x-axis and line parallel to y-axis. And this thing will happen when this thing is 0, then the y coordinates are equal. y1 is equal to y2. And this thing will happen when the x2 minus x1 becomes 0, and then y2 minus 1 y1 divided by 0 will be something divided by infinity is infinity. Something divided by 0 will be infinity, and that will happen when x2 is equal to x1. So any 2 points are given, we can find the distance between them, we can find out its inclination with respect to x-axis, and when tan theta, or if we find out the theta, we can also find its inclination with respect to the y-axis. So this rectangular set of coordinates are not the only way of representing numbers. There is also a polar coordinate. But before we go into that, let's probably look at some problems based upon the distance between 2 points. From 2 points, there may be more problem if we have a 3 point. If we are given a 3 point, then it becomes a triangle. A, B, C. And from this triangle, we may have questions about whether this triangle is equilateral, if the triangle is equilateral, then all of its 3 sides are equal. AB is equal to BC is equal to CA. This is the condition when the triangle is equilateral. If you are given the coordinates of the 3 points of a triangle, you can try to find out their length, and from the length you can tell that if the triangle is equilateral or not. The triangle may be isosceles. In an isosceles triangle, any 2 sides are equal. So either AB will be equal to BC. For example, if AB is equal to BC, then the triangle is isosceles. Or BC may be equal to AC. These 2 sides may be equal. Or AB may be equal to AC. So if you are given a triangle, find the length of all 3 sides and see if any 2 of them are equal. That will tell that the triangle is isosceles or not. A triangle may be right angle triangle if, how do you find a triangle is right angle or not? So what we do is, we try to find any one length, let us say AB, and find its square, and then if see that if this is equal to BC square, sum of the square of the other 2 sides, the triangle will be right angle triangle. But it can also happen that BC square is equal to AB square plus AC square, then also it will be triangle, or AC square is equal to AB square plus BC square. If any of these 3 conditions are satisfied, then the triangle will be right angle. So what is the way to do? What you do is find the longest length from this given triangle. What is the way to do is find longest length, then you square it, and then find sum of square of other 2 sides. If this square of the longest side is equal to the sum of the square of the other 2 smaller length side, then that triangle will be a right triangle. And then we can also say that we also have, in the similar way, we can find if a triangle has all of its angle less than 90 degree, or can have one of the angles more than 90 degree. How do we find this thing? That all its angles are less than 90 degree or one of its angle is more than 90 degree. In this case, the square of the longest, let us say we find and that the longest side is AB, and we find the square of this AB, and that becomes greater than the sum of the squares of the other two sides, BC square plus AC square, then that one of its angle will be more than 90 degree. And if the longest side comes out to be AB, and if I square it and it's less than the sum of the square of the other two sides, then that all of its angles will be less than 90 degree. These are called obtuse angle and acute angle triangle. So based upon the lengths of the sides, we can find out if a triangle has certain characteristics or not. Let us do some questions based upon what we have learned so far. Before we do that, let's also talk about a quadrilateral. So this is a quadrilateral, a general quadrilateral, and that quadrilateral is a parallelogram. How do we find a parallelogram? Means these two sides are parallel. If I call it A, B, C, D, and how do we make sure it's a parallelogram? In a parallelogram, we will have AB will be equal to CD. If AB will be equal to CD and AD will be equal to BC, and we have a parallelogram. How do we find out if it's a rectangle? In addition to these two, AB is equal to CD and AD is equal to BC, we must also have this length should be equal to AC, this length. AC is equal to BD. We can apply these kind of conditions to find a different type of a quadrilateral. So let's move on to a problem. So the problem is points minus A minus B, 0, 0, A, B, and A square AB are, first option is collinear. Collinear means all the 4 points are on a single straight line. Second option is vertices of a parallelogram. Parallelogram means these two sides are parallel. Parallelogram like this. It can be a parallelogram. It can be a vertices of a triangle, of a rectangle. And these, none of these. So there are different ways to solve this problem. One way would be to find the length of each of these sides and then try to see how it works out. The way I am going to solve is slightly different, even though we learned a lot about the lengths of the lines. So let's try to get a feel of it, what is happening. Minus A minus B. You should be able to plot minus A minus B. So let's say minus A is here a little longer and minus B a little smaller. So minus A minus B is going to be here. This is where minus A minus B. And the second point, call it my point number A, and my point number B is at origin. Even if it's origin, I'm calling it 0, 0. You could call it O, but let's call it B. And then the third point is AB, which means from here we go the same length here A and then B here. My point C is AB, and now I try to join this and then I try to join this. And my fourth point is A square, so it's double, maybe let's say if A is like do, then it will be something like do, much beyond here. And then finally AB is the multiplication of these somewhere here. A square and AB. This is what it looks like. But so it may be a point something like this. Okay, so it could be vertices of a rectangle, it could be vertices of a parallelogram, it could be collinear. But the way the points I am trying to plot, it looks like the collinear could be one of our choices. So we will first check these 4 points for being collinear. How do we check these points are collinear? If I can find the angle that each sections of the line subtend with x-axis, this is x-axis, and all of these angles come out to be same, then these 4 points are collinear. So let's say take AB. In case of AB, let us try to find out tan theta. The formula is y2 minus y1 divided by x2 minus x1. We are trying to find out this point line AB, how much angle it makes with the x-axis. If that is theta, then y2 minus y1 divided by x2 minus x1, let's call it 0 minus b is b, 0 minus a is a, so this is b by a. And let us call it tan theta 1. That is this angle. Now let's go to this section BC. For AB, we call it tan theta 1. For BC, let's call it tan theta 2. Again, that is y2 minus y1 divided by x2 minus x1. B minus 0 divided by a minus 0. This is going to be b by a. Which means this angle is all theta 1 and theta 2 are equal. What does that mean? This point A, B, C, they are in the same line. They are in the. Now let us check this point C and let's call it point D. For point CD, if this angle is theta 3, what that angle is tan theta 3 will be equal to AB minus B, y2 minus y1, AB minus B divided by x2 minus x1, a square minus a square minus a. And from here, on the top hand side, we can take b as common, b into a minus 1, ab minus, and the bottom we have a common and a minus 1. A minus 1 cancels out, we have b by a. So this angle is also theta 1, theta 2, theta 3, their all angles are same. What does that mean? That these 3 points are collinear. We can also verify it by finding the angle of AD. If this one is, let us say theta 4, then tan theta 4, that should also come out to be b by a. It will be AB plus b divided by a square plus a. This will be b into a plus 1 divided by a into a plus 1. This also comes out to be b by a. So the points are collinear. But in questions, you may have the points may be parallelogram or rectangle, and you can apply these conditions like this. So let's move on to do another question on 2D geometry. I will write the question and then you can pause the video and then do it. 2007, it says 2007, probably maybe IIT mains 2007. Let A HK B 1 and C 2 be the vertices of a right angle triangle. So we are given these 3 points, and these are the vertices of a right angle triangle with AC hypotenuse. AC is the hypotenuse. If the area of the triangle is 1 square unit, area of triangle is 1 square unit, then the set of values which K can take is, we are given 4 options. A is -1 3, B is -3 -2, C is 1 3, and D is 0 2. So on all such problems, you should quickly try to get a feel by plotting these coordinates. This is x coordinate, y coordinate. The numbers are small, so I can plot. If I can, I will plot it. So B is 1 1. So let us say B 1. This is 2. This is 3. This is 1 2 3. B is 1 1. So my point B is right here. And 2 1. So this is 2 1 is right here. This is point B. This is point C. And then AC is hypotenuse. So for example, this is a right angle triangle. So A can be right, like here. Okay. So this can be my triangle if I am A is here. But A can also be somewhere here. That can also be a right angle triangle. A can be here and A can be here. These are the two values that A can, and we need to find out if A is HK, if I can call it H and K, then that can have two different values, and that's what we need to. And we are given the area of this triangle is 1 square unit. Okay. What we know is that what helps us is that B is 1 1 and C 2 1. We know that BC is parallel to the x-axis, which means that this A is going to be always on this vertical perpendicular line. Both of these points should have H value should be same, only K value will be different. This line has to be perpendicular. Let's say this length has some value. This length we know is 1. And let's say this length is, I will call it P. And what we are given? We are, if the point A is in this direction, the upper direction, then we have the area of triangle will be given by half into P into BC, and BC is 2 minus 1, this is 1, into 1, that is given to be 1. That means P is equal to 2. And when P is equal to 2, that means the A will have y coordinate 2 plus 1 or 1. We don't know 1, but we know that this one will be 2 plus 1, 3. So our answer can be either this one or this one. This D cannot be the answer and B cannot be the answer. And in the second part, we know that the area of this triangle again is, let us say this whole length is Q, and half of Q into 1 is again 1, that means Q is equal to 2. Because Q is 2 and this is 1, so this must be minus 1. So that means the second value of this will be minus 1. So first value is 3 and then the second one is minus 1. So A will be our right answer. It's a good question. It may look a little difficult, but try to copy this question in a paper. By the way, if you are not taking any copy paper, make sure you keep a copy and pencil and try these questions. We are going to now learn a little bit about the polar coordinate. Polar coordinates, the way we express any point in terms of Cartesian coordinate, in the same way we can, to give you an idea of what is polar coordinate, let's say we are given a point P here. And the coordinates of this point P is given as X and Y. Then we know a few things about this point. Let us join my origin to this point P with this line. We know that the length of this line is the square root of x square plus y square. This is what we know. Because I can join this line with this length is x, this length is y, this obviously this length is square root of x square minus y square. And if I ask you what is this angle tan theta, then you can tell that. So first write OP is equal to square root of x square plus y square. And if I give this angle theta, then I know that tan theta is equal to y by x. So in polar coordinate, we specify this line, any point P, in terms of its length from this origin. We call it R, and the angle theta. So we say that the point P has coordinate R and theta. If we are given a Cartesian coordinate xy, then we can convert it into the polar coordinate using the formula R is equal to square root of x square plus y square, and theta is given by, you can write it as theta is equal to tan inverse y by x. This is the polar coordinate. So in many problems, it is easier if you, engineering problems or any other question, if you deal with the polar coordinates. Lot of problems is easier to deal with the Cartesian coordinate, but there is a class of problem which will be more easily solved if you use the polar coordinate. For example, if I give you a point P and ask you what will be the new coordinate if you rotate it by another angle theta, keeping this axis, then R remains same, theta will become theta 1 plus theta 2. Similarly, if you are doing any rotation kind of thing, anything that has to do with the rotation and anything, rotational mechanics and things like that, will be easier with the polar coordinate. Anything with a rectangular movement in x and y both directions will be easier with the Cartesian coordinates. The next question is very important, not only for the coordinate geometry but also for vector mechanics, and this is that if you are given a point P r theta, what is its Cartesian coordinate? So I am given this point P r theta. I want to convert it into the Cartesian coordinate. What is its Cartesian coordinate? Its x-axis. This is the length that will be its first x-axis coordinate, and this is the length. If I know these two lengths, I can express this into Cartesian coordinate, and for which we know we have two formula. if I call it distance x and let's just call it distance y, and I can apply the sine theta and cos theta formula. So sine theta will be equal to y divided by r, and from here you will get y is equal to r sine theta. Which means that this point P has y coordinate as y sine theta. And if I apply cos theta formula, cos theta will be equal to x divided by r, or x equal to r cos theta. That means this point P will have x coordinate as r cos theta. This is r cos theta and r sin theta. If you have started studying physics and you know the resolution of vector, then if this is a vector quantity, then its resolution along the x-axis is r cos theta and its resolution is along the y-axis is r sin theta. This is very similar to that concept. Here we can convert a given polar coordinate to the Cartesian coordinate using r cos theta and r sin theta that we will use in the physics also. Let us do another problem. I will explain the problem and try to do that. The question is, we are given a triangle and the triangle has coordinate 3 points. A is 0, 0, B is 3 root 3, and C is, let us say, H, and K. Triangle is equilateral. Find HK. We are given a equilateral triangle and two of its coordinates are given. You need to find out the third point. It will be very easy. When is the triangle equilateral? AB is equal to BC is equal to CA. And we can find AB as square root of x1 square minus y1 square plus x1 minus x2 whole square plus y1 minus y2 whole square. 0 minus 3 whole square is 9 plus 0 minus root 3 whole square is 3. This is AB square. If these lengths are equal, then their squares will also be equal. So let's do it, simplify it and do it like this. And we will not deal with the square root. We will remove the square root. So this will be 9 plus 3. What is BC square? 3 minus h whole square plus square root of 3 minus k whole square. What is CA square? Simply h square plus k square plus k square. So from this one we get two equations. If I equate this with this, I get one equation, h square plus k square is equal to 12. Now the second one, don't take this one, again you will get h square and k square. Try to take this one because h square and k squares will cancel out. If you take this equation, then h square and k square here cancel out. You get minus 6hk minus 6h plus 9, and here you get minus 2 root 3k plus 3 equal to 0. This is equation number 1. And this is my equation number 2, h square and k square cancel out. And from here, we can get 9 plus 3 is 12. So 12 is equal to 6h plus 2 root 3k, 2 just divided by 2, 3h plus root 3k is equal to 6. This is equation number 2. These two equations should have two solutions. How do we solve it? I am going to multiply this equation by 3. 3h square plus I will make it root 3k whole square is equal to 12 into 3. Because I have root 3k here, and that I can substitute by 3h square plus 6 minus 3h whole square is equal to 12 into 3. Okay. 6 minus 3h square. Let us take 3. Let's take 3 out here. So 3h square plus 3 into 3, 2 minus h whole square is equal to 12 into 3. And cancel one of the 3. 3, 3, 3 cancel. H square plus 3h square minus 4 into 3, 12h plus 4 into 3, 12 is equal to 12. Okay. 12 cancels. 4h square minus 12h is equal to 0. 4 common. 4h common. H into h minus 3 is equal to 0. H is equal to 0 or h is equal to 3. We have two values of h. H is equal to 0 or h is equal to 3. And then we can substitute this value here. If h is equal to 0 and this is 0, square root of 3k is equal to 6. So k will be equal to 6 by square root of 3. K equal to 6 by square root of 3. We can make it. Let us multiply. सॉरी यहाँ पे फोन आ गया था. इसको रख दो बेटा, इसको रख दो, बाद में कर लेंगे बात. So this is becoming square root of 3 multiplied on the top and bottom becomes 2 root 3. And if I put h equal to 3 here, then square root of 3k becomes 6 minus 9 minus 3, or k is equal to minus root 3. So these are our two solutions. So the one solution is 0 to root 3, other solution is 3 and minus root 3. Why do we have two solutions? This is based upon what we learned about the distance between 2 points. Now what we are going to do is we will try to look at what is actually happening in a one point is 0, 0, the other point is 3 root 3. 1, 2, 3, and root 3 will be around 1.7 somewhere here. This is 3 root 3. And I join these 2 points. O, this is calling A and this is they are calling B. And this is a equilateral triangle. How do we get a equilateral? One point will be somewhere here, but this point may also be somewhere here. This point may be, so one point is this one, 0, 2 root 3. This here, 0, 2 root 3. 0 means on the x-axis we are not going anywhere. On the y-axis side we get 2 root 3. And the second point is 3 and then minus root 3. This is why we have two solutions. We can also solve this problem more simply if we know the polar coordinates. Let us remove everything. All we know is this line. That is all we know. And in this line, what is the length of this line? Let us find the length of this line. length of this line AB is equal to square root of 9 plus 3, which will be equal to 12. 12 means 2 root 3. So this is 2 root 3. And let us find this angle tan theta. Tan theta is this length square root of 3 divided by 3. Tan theta is equal to square root of 3 by 3. This is 1 upon square root of 3. And this happens when theta is equal to 30 degree. From our trigonometry, we all know trigonometry. Now what I am doing is, when this angle is 30 degree and I need to create a triangle, then this angle, this angle is 30 degree. Now this angle must be 60 degree. If I have the triangle has to be equilateral, then this angle has to be 60 degree, this angle has to be 60 degree, and this angle also has to be 60 degree. This angle 60 degree means this whole angle has to be 90 degree, and that is possible only when this angle is 90 degree. And we know that the length of this side AB is 2 root 3, so this also will be 2 root 3. This length will be 2 root 3. And when this length is 2 root 3, then the coordinate of this point will become 0 and 2 root 3. So that is an easier way of solving the same problem, especially if you will be given a coordinate. On the other side, this angle is going to be 60 degree. That is the other way. This angle is 60 degree. And this angle also has to be 60 degree. And this angle is 60 degree and its length is 2 root 3. When this angle is, no, this angle 60 degree, this whole angle has to be 60 degree. And its length will be 2 root 3. And when this angle is 60 degree, then this angle has to be 30 degree. What we have is another point C such that it is making 30 degree from this x-axis and it's of length 2 root 3. And now we can find out this length and this length using 2 root 3 cos 30 degree and 2 root 3 sin 30 degree. So this length will be 2 root 3 cos 30 degree, which is 2 root 3 multiplied by root 3 by 2, which will become 3. So this length is 3 and this length is 2 root 3 sin 30 degree from polar to rectangular coordinates. So this will become 2 root 3 sin 30 degree 1 by 2. This will be root 3. But the coordinate of this point, because it's a negative y direction, so this will become root 3. So its coordinate will be 3 and minus square root of 3. So that is, check if I make any calculation. But in some cases, polar coordinates will make the solution of a problem easier. Can keep trying more solution problems here. We are already about 1 hour, but I will try to give you one more concept before we close on this chapter. Let us say I have given you 2 points. One is coordinate x1, y1, another has a coordinate of x2 and y2, and I join these points. And then I asked you to divide this point in the this line in the ratio m and n. For example, I asked you to divide this ratio 2 is to 1, or I can ask you 4 is to 1 or 1 is to 1. And what is the coordinate of this point, let us say R? Find the coordinates of R.